we are going to start our webinar on artificial intelligence from pathologist's perspective, a live practical demonstration, which doesn't need any coding. It will be hosted by Dr. Atul Tiwari. He is MD Pathology and has done his diploma in artificial intelligence, diploma in bioinformatics, and is pursuing masters in artificial intelligence from UK. He is doing online consultation for the startups and researchers and taking short online courses also. He has many publications to his credit. And I thank Dr. Atul for taking our invitation and receiving it. And I request Dr. Atul to please continue with this topic.
Thank you, sir. Am I audible clearly?
Yeah, clearly.
Okay. I will share my screen now. So my screen is visible now.
Yeah,
visible. A very good evening to all. Okay, thank you, sir. A very good evening to all.
Yeah. Full screen you can do.
Yes, sir. Basically, I wanted to demonstrate. That's why I'm not switching to full screen so that I can switch back and forth now. Okay. So, very good evening to all. My name is Dr. Atul Tiwari, and today I'm going to present a small demonstration about how, as a pathologist, we can create our own model. So, it is a basic artificial intelligence from pathologist perspective. So before going into the talk itself, just a brief information about me, as sir has already mentioned, and I am an MBBS DCP MD pathology, and I have 2 diplomas, one in artificial intelligence and another one in bioinformatics. At present, I am pursuing masters from LGMU University in artificial intelligence, and I also provide consultation to startup and researchers. Along with that, I take short online courses about artificial intelligence. So before coming to the topic per se, this is the thing that I wanted to share with you, that most common AI learning goals for doctors. This slide was collected by Dr. Anupama, ma'am. She did a poll in one of the groups that I am a member of. So as per her polls, it was found that most of the doctors, they want to learn AI because they want to have a basic understanding to adapt for the change. Some of them wanted to understand how AI can make administrative tasks easier. Someone wanted for content creation. There were very few who wanted to develop models or who wanted to learn it for research. And out of those, hardly a few people who already know coding. So most of them don't know coding. That's why a thought came into my mind after discussing with fellow doctors that is there a way that as a pathologist or as a doctor, can we create a model by ourselves without even the knowledge of coding? That's when I was figuring out, and I shortlisted some of the tools, out of which one of tool is freely available that I have already shared with you in the group, that is Orange Data Mining. Today I will be demonstrating on that. But before the demonstration itself, let me give you a brief idea about how I will proceed and what is artificial intelligence in just 2 more slides, so that you can have a basic idea. I am assuming that who are attending this talk, they have very little or no information about AI and how we use it in our day-to-day life in creating a model. So AI is basically, if the computers are designed to mimic human thinking and problem solving. In terms of pathologist, it helps perform tasks like recognizing patterns in medical images. Medical images are mostly there in case of radiology and pathology. In radiology, as you must be aware, that AI is taking over quite fast because everything is computerized. So running AI model and algorithm, that is quite easy. As pathology, we have a roadblock in case of digital pathology because we need whole slide scanner that are not mostly available in all the institutes. So that's why we are lagging behind, but it is not the case for developed countries. They are working quite fast, and their products, the models, they are like very robust. It's almost like they are diagnosing by themselves. So that is the reason. That's why I wanted you to be aware about these changes and how you can adapt to these. With this, I wanted to tell you three terms, that is artificial intelligence, machine learning, and deep learning. These three terms are quite common in while learning about AI. So sometimes people think these terms are synonymous, sometimes they think they are of different domains. So basically, what are the relation amongst these? So the artificial intelligence is a quite broader term. So it encompasses, there is a subset of AI that is known as machine learning. AI encompasses so many things, out of which we generally talk about machine learning and deep learning. So machine learning is a subset of AI, and it deals with like how computers or machines, they can use the statistical methods to enable machine to improve the experience and ultimately come to a diagnosis. Deep learning is a subset of machine learning where the models that we create uses multi-layer neuronal network approach. So today we will just briefly touch the machine learning part. We won't go into the detail of deep learning, but those who are really interested in learning AI with terms of pathology, specifically I'm talking about, the deep learning is the real part which you will have to eventually learn, because as a pathologist in day-to-day life, we deal with the microscopic slides. Microscopic slides are the images. So statistical data that are quite limited with respect to pathology, but slides, they are infinite. You name the organ, you can create your model. You can create for inflammatory diseases, you can create for tumor cells, or you can create for any diagnostic point of view. So that's when deep learning comes as a handy tool, but it is a little bit advanced, and we are going step by step. So today we will just see what machine learning is, what are the steps, and how we can create our own model. I hope by 8 p.m. you will be able to create your own machine learning model, those who are following me with the practical. So these are the steps that I want you to know, because these will be the same steps I will be doing in the practical also. The first step is data collection. What do I mean by this? Data collection means gather the relevant data, same as we used to create our master chart in the thesis. So it is almost same. We can create it in Excel. Only thing is, we need to be precise while creating it, because ultimately our data set will be the one thing that through which we will be creating our model. If our data set has some useless things, our model will be confused. Or if it is missing some of the data that is quite important for creation of the model, then it would be very difficult for the model to be accurate. So that's why we need to be first sure that what is my problem statement, what data I need to be handling before creating a model. This is the prerequisite. You cannot decide about your data after you are already running a model. So that's why I'm saying data creation is data collection or creation of your database is the key for creating any model, whether it is machine learning, deep learning, GAN, you name any AI architecture, data will be there, and you need to create your data set beforehand. So after data collection, as I mentioned, data can be in Excel format, but in general, we use the statistical data or the machine learning data in CSV format. What is CSV format? If anybody knows, you can write it in comment also, so that it can be an interactive talk, not just a one way. So CSV is comma separated values. It is just that in case of Excel, everybody has used Excel some time in their lifespan. Excel has some rows and columns. CSV is same thing. All the values of any cell, for example, row A, column 1. So the value is separated by comma, simple. So it is a simplified Excel format. We can say there are no charts, no graph, nothing images, only comma separated values that are there in the Excel record. So this is the most easiest data set that we can create. If our data set has some missing values, then comes the process of data pre-processing. In the data pre-processing step, we impute the data. For example, if if I take the example of today's lecture only, I am using a breast cancer data set that is freely available on the website. And if there are some FNAC features like radius, texture, diameter, and all the things, suppose if the radius of a nucleus is missing, is it important? Yes, it is important, because the radius is the one of the thing, or the perimeter is one of the thing through which we can decide whether the particular nucleus is benign or malignant. So that's when we need to decide, if our data is missing, should we include that particular data in our data set? Should we delete that entire row? Or can we use any statistical method such as mean, mode, median, or standard deviation through which we can generate our new data? So after data pre-processing comes feature selection. Feature selection means, suppose we have so many data. We have, in case of breast cancer, even if we include age, gender, IDs, we have histopath slide ID number, cytopathologist ID number, or patient HID number. Do we need that thing? No. So we can delete those particular columns, or we can ignore those particular columns during data pre-processing. And after, in case of feature selection, we will decide, suppose these 20 columns or 20 variables are important for me. These 20 variables will be called as independent variables, through which we will diagnose our dependent variable. That is the diagnosis. Either our particular case is benign or malignant. So in case of feature selection, I want you to remember one term, that is PCA, principal component analysis. I can't give example and classification of all these things. Those are quite elongated. So in single talk, I cannot describe it. Simply, I want you to remember one of the most important feature selection mechanism is PCA. If I get enough time today, then I will demonstrate you how will we use it. Otherwise, we will simply create one model with basic knowledge. Then comes model selection. So there are different types of models, mechanisms, or algorithms to be precise. Most commonly used are supervised machine learning and unsupervised machine learning, which are further subclassified into multiple names are there: regression machine learning algorithm, classification machine learning algorithm. Out of these, as a pathologist, what is the most important part is we will be using classification machine learning. If anybody wants to selectively learn those aspects, then I would say the classification machine learning is one of the most easiest and important thing for the pathologist. Then comes unsupervised machine learning. These are also helpful to define if our data set, suppose our data set has benign and malignant label there, then it is supervised machine learning, that we already know the diagnosis and we are classifying our data set as per the our diagnosis. In case of unsupervised, what happens is we have a data. Suppose I will show you one data set. This is the breast cancer data set that I will be using. And so it looks like this: that diagnosis M for benign, M for malignant, and B for benign. There are other attributes such as radius, texture, perimeter. All of these are there. Suppose if the diagnosis is not provided for the creation of model, only the values are given to the machine, that okay, if a nucleus has a radius of this much value, texture is this much, and perimeter is this much, and so on. And can you decide a pattern? If we ask machine, so it might find out that okay, there are two types of population, one having these much of values and another one having these much of values. It won't find out that these are benign or malignant, because we didn't initially tell the machine. That is known as unsupervised machine learning. So some of the common machine learning algorithms are decision tree, random forest, SVM, naive Bayes, KNN, logistic regression, gradient boosting, neural network, out of which around 4 or 5 we will try out today. There are some hardcore mathematics associated with each of the machine learning algorithm. As a doctor, we don't need to learn those things. We only need to identify that, okay, for my problem statement, which machine learning algorithm works best. So that, for that, read as many articles as possible. I have given you the most important machine learning algorithm here. You can find out the names in any article that you want to read. These are the most common names that you can read in any article. And today I will be demonstrating these. Out of which, if in an easy language, if I demonstrate decision tree. So decision tree is nothing like a tree-like model, in which decision-based data features are there. For example, this is our breast cancer data set decision tree only. So machine has identified that the radius is the most important thing to decide as a first step. So radius less than equal to 16.795, it splitted the data set into two parts. After the split of on the basis of radius, then it decides the next key feature through which it can further subdivide and come to a diagnosis. So that's how step by step it ultimately reaches to a point where our data set can be categorized individually into benign or malignant. So that's how a decision tree works. And this is the most easiest algorithm in the field of AI that we can demonstrate via this easy graph also. As we move forward, random forest SVM, these are more complex. It is not easy to demonstrate or explain in a plain English language only. Then there will be some maths associated with it. But as I already mentioned, these are already validated machine learning algorithm. So for creation of our model, we don't need to go into details of maths aspect of these model. So now comes the live demonstration part. For the live demonstration, I'll be using Orange data mining tool. Although in the group, I had already shared that this is the tool that I will be using, Orange data mining. If anybody wants to follow along with me, I had messaged that he should have already downloaded this software and installed. I had already created a video for this. And if you have not downloaded it yet, I would suggest not to download right now. You can download it, but not to install right now because it takes around 20 to 30 minutes. So for now, you can focus on the screen that I'm sharing. It is easy. You can also do it by yourself later on. If you have any problem in that, you can ask me anytime. So this is the UI after installation that looks like for the Orange software. So as you can see, it doesn't look like we need to code some place. It is just like our Word, Excel, PowerPoint, similar thing kind of thing are there. At the top, there are file edit view like tools. On the center part, that white part, it is our workspace area. And on the left part, there are some tabs known as data, transform, visualize. Each one has certain widgets. Some of the widgets that we will be demonstrating today, some are advanced and some we don't require. So the most useful widgets I will share right now. First thing is, if you can recall, right now, I want you to focus on these steps. I have demonstrated till model selection only. After that comes model training evaluation that I will show you right now. So first step was data collection. So data collection, I have already shared that there is a data set for breast cancer FNAC features. This is available on UCI website. It is freely available from some US institute. I'm using that data set only. And one of the paper that is already published, there are several paper published from this. One of the paper that I have shared in the group also, this is about breast cancer prediction using FNA features with supervised machine learning. So this, as you can see, this paper was published recently only in Jan 2023. So you can also think that the information that I'm sharing today is not yet outdated. Even though it is easy to do, it is not yet outdated. If you have gone through this particular article, you might find that they are using complex Python programming to create the model. I will be using the same data set, the same methodology, almost similar methodology, but without using any coding. So now coming back to our Orange tool. So let us first load the data set. So for loading the data set, if you are already following me now, you can follow all the steps that I'm doing. So there is a file visit on the left side of the screen. There are three ways through which you can load a visit into the workspace area. First one is you can simply select and drag and drop it. Another one is you can single click on the visit. That way also it will load on the screen. Third way is simply right click on the workspace area and it will list down all the visits that are present in the orange tool. So the first step is that we need to load the data set into our workspace area. So I will use file visit for that. So my first visit is file visit. If I double click on this, it will ask me to select the data set. Right now, already my the desired data set is selected. In your case, if it is not selected, then you can use this folder selection tool for loading your data set, through which you can locate your data set and load it. The key important thing that you should not forget while loading the file or the data set in the orange is at the bottom, there are all the columns mentioned that are present in the data set. Just have a quick look at these columns. If you see that there is an ID name, there is a column named ID, it has a value of numeric. Its role is feature. Similarly, for the radius mean, texture mean, perimeter mean, all of these are my features through which I will diagnose. I will be getting my diagnosis. So the second column would be my target column. In your case, if you are doing it, it might be set to feature, because this is the first time. At that time, by default, Orange don't know what is the feature and which one is the target. So I had already selected it as a target. That's why it is showing it like this. Apart from this, you can see that in the end, there is one more column named feature one is being shown. If you see the data set, there is no column named feature. There are only 16 columns that are present. Why is it happening like this? I intentionally didn't correct the original file and put it like this only, so that you get to know that sometimes while creating the data set, still a simple mistake might happen, and that's when we find out that, okay, something has happened and one more column is being shown. So if I examine this particular data set in a simple notepad, then you can see that all these columns which were shown in Excel, ID, diagnosis, they are present there. But in the end, there is one extra comma is there. You can see fractal dimension word. After that, there is one comma, because of which the Orange software got confused that there is one more column there, but it is not named. So that's why it automatically named the column as feature one. But anyways, if by mistake we did this mistake, and then we can correct it later on in the Orange itself. I will show you how. But before that, we will come back to our next visit. Once you have selected the diagnosis column as your target value, don't forget to click on apply. This will save your data set like diagnosis is our target value. It has B for benign and M for malignant. So now we have loaded our data set in our visit. Next thing that we should do is we should visualize the data set in Orange itself. Like I have demonstrated you showing by in Notepad, I have shown you this data set in Excel, but we should always visualize in Orange. For that, we will use another visit that is named as data table. So I have loaded data table. Okay, I forgot to show you that how these are connected. If you have done file visit, you have loaded it. Next visit is data table. I can simply drag and drop it. I can single click it, depending, or I can right click and use data table. Anyway, I can load. If I load a visit through this mechanism, then I need to connect our previous visit to the newly loaded visit. So every visit has either dotted line on the left side or dotted line on the right side. Left side dotted line, these represent that it wants to have something as an input. Input means whatever we are providing to the visit. And on the right side, there are dotted lines. It means it is giving some output. Now we need to decide that how will we use that particular output. So as you can see in file, there is nothing as input dotted line. So file only has output. We have loaded our data set in file visit. Next, we need to connect this with file visit with the data table. So we can simply click on the output side of the file and drag and connect it with the data table. So this is how we can connect. We can also simply click and drag and create a line. And if I release the mouse button now, then it will simply ask me that, okay, what visit do you want to load here? So I will select data table. In any way you are comfortable with, you can load the visit. So now my data file visit has linked with data table. File visit has breast cancer data set. So if I double click on data table now, I can see that my data set is shown in the orange software. So in the initial only, I selected diagnosis as my target column. So if on the left side, I see that there is brief history, there are 569 rows, 32 features, and 3.1 missing data, which I was mentioning earlier that if missing data is there, then what should I do? Then there is a target column that is named as diagnosis with two values, M for malignant, B for benign. And there is no meta attribute. For today's talk, let's leave meta outside. It is just an additional information. Next thing, if I focus on the data set, there is the next column, ID. It was required while we create our master chart in the thesis, but for computer or machine learning model, the ID column is not required. If I provide somehow ID with that, my model will be very bad, because it doesn't matter if the patient ID was 1 and it was labeled as malignant, or the ID was 2 and the label was benign. But what matters is if my values, radius, mean, texture, these parameters, what are their value? Those will decide whether the particular nucleus is benign or malignant. So I need to selectively remove the ID column. That is the first column. And in the end, as I shown you earlier, there is one extra column named as feature 1 that was created due to the mistake while creating the data set. So these two columns I need to remove first before moving ahead. So to clear our data set and select a specific column only, for that, in the transform tab, there is one visit named as select column. From now onwards, mostly I will be loading the visit from just by connecting my dots with the output table and the next input visit. So my next visit would be select columns. In select column, you need to remember two things. First one is when I double click on this, it will show me 3 columns. One is ignored, another one is feature, and there is one more named as target. If in the initial step you forget, those who are raising hands can put the question in the chat. I can see easily there, and if needed, I will answer there. Otherwise, in next half an hour, I won't be able to complete it. So there are 3 types of values: ignored, features, and target. My screen looks like this. In your case, it might look like this, that there are 32 features and 1 target. And if initially you made a mistake of not selecting your diagnosis column as target, it might even look like this, that diagnosis is also in your feature part, not the target part. So how do we correct these mistakes? We can simply select the diagnosis from the feature and drag and drop it to target. That's how we will tell, or is that diagnosis column is my target column. That is what I wanted to diagnose. That is what I wanted to predict. And there are two more columns, that is ID and feature one. These are ID and feature one. These are not useful for me to create any model. So I will simply drag and drop it to ignored category. That's how I selected that my radius mean, texture mean, perimeter. I'm not naming all these features. There are 10 features, and there are some derived features like mean, standard error, and the worst value of each and every feature. So in total, they created the 30 features. So now my data set is prepared. I have selected the column that I want. Next thing, what I need is next data set. Before coming to next data set, let me just deviate from this little bit. If you can see, if you have read that article, this feature was not there in that article, but you never know where you might need it. There is another widget named as rank. It is an important widget. We can also use it in programming, using programming, which I will show you later on in the end, just for a brief second. Before that, I forgot to mention one more thing. While selecting, changing the properties in select column, I mentioned there are two things that you should always remember. First one is to decide what parameters are useful. Second thing is, by default, the connection between data table and select column, it is selected data to data. It means that whatever data I am selecting in data table, only that will be processed to the next widget, that is my select column. For example, if from select column I connect another data table, this time my data table should have all the columns and rows except ID and feature one. But instead, what happens? I am seeing only one row, the first one. And yes, my ID column is removed and the feature one column is removed. But what happened to my other rows? In it is not showing because I have selected the feature as selected data to data. So if I select multiple rows on my data table, you can see after select column, it will be appearing here. If I select another rows, it might appear like this. But for this study, I want my whole data set. So how do I change it? I need to simply double click on this, select data, and I need to change the connection. This link I need to change. By default, it is selected data of data table with the data of select column. If I hover my mouse on this line, there is a cross button and there is one more option, clear all, on the left bottom side. By this, I can remove the connection between these two and I can create my new connection for whole data with the data of selected columns. So now if I see, it doesn't matter if I selected a single row or a multiple row. In the output, there will be all 569 rows. This time you are seeing there is no missing data because the missing data of this data set was in feature one column. That is anyway we have removed. If there is still any missing data, then we need to use impute features, which I will talk about next. Before that, I was demonstrating you the rank feature. If I click on rank feature now, as you can see, so far we have not created any model. The rank feature is there are multiple scoring methods available. These are statistically validated methods. By default, right now I have selected chi-square. So if I use these features, it will use the values given in the data set and it will arrange all the columns statistically. Which one is the most important? So for example, according to chi-square algorithm, the radius worst is the most important feature for this data set to diagnose. So if there is a need to feature selection, if you remember this step, feature selection. So if there is a need to select only few columns, for example, if I want to study only with the best 5 parameters, So I will use these 5 because these are highly associated with the correct diagnosis. In making correct diagnosis, if I go at the bottom, I can see that symmetry, SE, smoothness, standard error, these have lesser impact on the diagnosis part. So I won't be using those values in diagnosing, so that my AI model would be lightweight. It won't have so much of load on CPU. Similar to chi-square, there are other parameters, other methods of scoring methods are there. That is Gini decrease, information gain ratio. These all are important parameters. You can have a look at all of these, all of those, and can ultimately decide which parameter suits you best for the model creation. So this was rank visit. There are many more things in the rank visit, but right now I can't go into those much detail. You can explore it yourself, or maybe some other day we can discuss about it. For now, we will move ahead with our journey to create an AI model. So next thing to create an AI model is pre-process our data set. For pre-process, we have a visit named as pre-process. Now, what do I mean by pre-process? If you see, there is data pre-processing. It means cleaning and prepare the data for analysis. So in pre-process, if I double click on this, there are multiple features that are associated with pre-processing. For example, there is impute missing values. So it is suggesting that if I have a missing value in my data set, I can have 3 options. Either I can use the most frequent value or the average value for the missing data. I can replace it with the random value, and I can remove the missing value. It is up to us that which option we should take to create our model. So it always depends on the type of data set and our aim to study. In this example, there is no missing value, so I won't use this feature of pre-processing. But if you remember, from our data table, if you can see, our values are not normalized. By normalization, I mean, if you see radius for the first row, there is 17.9. For second, 20.57. So I don't know from what is my lowest value and what is my highest value. And even if for this data set, I can, okay, you can say that, okay, from Excel, I can arrange the data set in ascending or descending order, through which I can know that this is my minimum radius and this is my maximum radius. But can you predict a radius for the upcoming new slide that you are going to provide to your AI model? You can't predict. That's why in the initial phase only, we need to normalize our data set. By normalization, I mean is every value, every numerical value, we will convert it in somewhere between 0 to 1. So to create it between 0 to 1, we use pre-process tool. There is an option normalize to interval 0 to 1. If I select this one, there are other options and they have their respective use cases. I can't demonstrate that right now. So if I use normalize to interval 0 to 1, and by default, it is saving automatically. And after pre-processing, if I see the data again, for seeing the data, now you might be remembering that we need to use data table visit. So if I load the data visit table now and double click on it, can you see the difference? My radius mean has been converted to some, it was earlier 17 point something first row and 20 point something second row. So now it is converted to 0.5210, and similarly, all the values, not only radius, texture and everything, that is converted somewhere between 0 to 1. So there is a mathematical formula associated with it. You can read it in any of the article there. There are so many values, so many articles are there explaining this. So my all numerical data has been converted or has been normalized. Now my data is ready for the next step. So what would be my next step? Now I'm moving forward for creating AI model. For that, I need to use a visit named as data sampler. In data sampler, if I double click on this, there is an option. By default, it is selected only in the beginning phase. when you are doing it for the first time or first 10 times, you shouldn't change the values. So I will simply explain you what it is saying. The first radio button, that is fixed proportion to data. It means it is selected as 70%. So it means 70% of the data that is there in our data set, 70% of these randomly will be chosen for training part. Training means to create our AI model. Machine will train on that 70 part. The remaining 30% of my data, it will be unseen to the machine until I create a model. So my machine or the AI model that I will be creating won't be seeing that 30% data. It will be further used to test the accuracy of the model. That's how we get to know if my model is working properly or not. If my test output is good, I can launch it in market and we can incorporate with our machine or existing tools, or we can create a new tool. If the performance is bad on the test data, then we need to somehow tweak our data set or the parameters. We need to figure it out. How can we modify our AI model? So for now, I am using the default setting only, that 70% of my data will be test data. I am seeing one question, the numerical value. For that, I have already mentioned you, ma'am, that in pre-process, there are one more thing. You can little bit advanced. For example, this edit domain, it is there. If I select my column with the edit domain, and if I click on this, glad that you asked this question. You remember for benign and malignant, I didn't convert it into numeric values. So I can convert like this on also. For example, there is benign, and I can keep benign as 0. So I will simply edit my domain. So this will designate B for 0 for benign. And if I double click on M, it will create, malignant would be 1. So now I converted it with my diagnosis column as 0 or 1. So if I see another data table, this time, instead of seeing benign and malignant, I will be seeing 1s and 0s. So that's how we can convert. But then, that being said, it is not like that if there is a word that nucleus is benign. These many words, it is not easy for us to convert in 0 and 1 or like categorical numerical format. So we need to create our data set very carefully. So this was the answer to your question. And now we will move ahead. So I selected my 70% data as my test data. So after selecting the test data, next thing would be to select a model and connect it with the test and score. Now is the time to create, for which you are waiting from the for more than 45 minutes now. We will select our machine learning algorithm model now. So what were the machine learning model algorithms? I mentioned you in the PPT also that these are the most common machine learning algorithm that we see or that we do in the initial steps. And some of these like random forest, SVM, KNN, these are still having very important features that we do in daily life for creating AI model. In fact, some of the AI model are only based on random forest or KNN only. These are so good so good algorithms. So for example, since we can easily interpret the decision tree algorithm, so I will start with the tree. So this time I'm connecting my data set with the tree visit. So as you can see, I have connected my tree in orange. Decision tree is named as tree only. So I have connected tree visit with the data sample. If I double click on the connection, then I can see data sample is connected with the data of tree. By default, it should be like this only. What do I mean by remaining data here? Remaining data means the 30% of the data that we want machine not to see before creating the model. So right now we are creating the model. So we will be selecting data sample only. This way, we will be selecting only 70% of the data. So I will click OK. My machine algorithm is selected. Now the next thing is I want to process it. So I will create one more output and connect it with the test and score. I will demonstrate you what it will do. Just follow me for a few seconds. As you can see, with the test and score, I chose data sample with the data. Here also there was an option to choose remaining data. Right now, I am not selecting it. So third step, I will connect my tree algorithm with the test and score. And I want you to notice on the test and score visit, there will be a quick move, circle, black circle that will be going around. It will be very fast. That's why I am telling you in the beginning only. So it has processed it. Now, if I double click on the test and score, okay, let me delete this and show you. If I didn't connect my tree with the test and score, I don't see anything. This window is for showing the model that we have created. So here the model name will come. After that, our model's area under curve feature will be there. So this is an evaluation matrix. Accuracy will be there, F1 score, precision, specificity, all the features will be shown here. So right now it is not showing because we have not connected any our data set, our machine learning algorithm. So now I will connect it and it is processed. So now if I double click on this, I can see that my tree model has been created with an area under curve of 91.9, accuracy of 93.7%. So this is our first model that we have created without using any code, simply using a single PPT that what are the steps that we require to do. You can simply follow these steps and create your own model. This time its accuracy is 93.7, specificity of 92.3, and all other evaluation metrics are there. Here, I want you to notice one more thing. There are on the left side, there are so many parameters. By default, the orange chooses cross-validation and number of folds are 10. What do I mean by cross-validation? That is a little bit difficult for you to understand right now, but you can assume that it is more accurate than not using it. Maybe some other time or you might learn about it. Every standard article uses 10 folds of K cross validation because that way we can validate our model. So if you are checking with state of the arts model, any research published model, then you should check your model's accuracy using cross validation feature. So now the first model is created. As I mentioned, tree model is the very easy model. It is like if and else. I can visualize easily how my tree model performed. So for that, I need tree viewer. So I connected my model with the tree viewer. And if I double click on this, you can see this time it used area worst as the most important feature. That's how it decided that my model, my AI model will perform. There are so many questions. I think I will take those in the end. So this is the area worst. Area worst is the most important feature as per decision tree algorithm. I'm clearly saying it is according to decision tree. I'm not using random forest right now. I'm not using neural networks and others. This is easiest approach. Next thing, in general, how we do is area worst. If I create an algorithm like this, generally as humans or as pathologists, what we do is suppose area is less than this and area is less than this value, greater than this value, then we will create the next tree. But in case of decision tree, it is little bit more advanced. For example, area worst, here it has decided that if the value of area is more than 0.170, then by default, machine is sure that this particular nucleus is malignant. It doesn't require any other feature. But if the area is less than equal to 0.170, then it is confusing. For machine, it requires another feature to differentiate between the malignant and benign nucleus. So next, machine find out that this concavity, concave point worst, it is the most important feature that can further subclassify. So the next tree would be using concave point worst. And by this, we get the leaf that if value of concave point worst is less than equal to 0.45, then it is definitely benign for machine. But what is in between? In between, machine is still confused. So step by step, it is deducing that whether the particular nucleus is benign or malignant. And it is also mentioning that how many data it differentiated using this particular approach. And ultimately, all the values, all the cells have been classified either in benign or malignant. In case of decision tree, it was easier to view how machine approached the case. But for others, it is difficult. For some, it is not impossible. There are ways that is known as explainable AI, but that is really very difficult to demonstrate even in 10 classes. So for now, we will proceed with the next model. That is the most common model that anyone uses in his pay or her paper. It is known as random forest. So I will simply connect the random forest with the data table, my data sampler. Random forest. Now, if you see, I connect the random forest with test and score. It is processing because it is a little bit heavier. It took some time. For random forest, if I see, my accuracy is increased to 95.5%. That's why it is favorite ML algorithm for most of the researcher. It performs very well and it is easier to do, very lightweight, and it can process in fraction of seconds also. So if I see, my train time is 1.6 seconds. So that's how I created two models now. I will demonstrate just one more model and then we will move for prediction. Now you can use KNN, gradient boosting, SVM, AdaBoost, Naive Bayes. All these names I showed you, neural network. These are important ML algorithm that are being used. You can use any one. I have done this experiment on the 9 features, 9 types of ML algorithm, and out of which I have got an accuracy of this one is there 98.6%. And if you go through the article that I shared, most of the accuracy that have been shown in this article, that there are 97%, 95%, even the 100%. This particular article is mentioning at the here it is showing how it is 100%, 98 plus plus minus 2%. So that's how it is saying. So 98%, the article is using Python, complex programming language. So this is not an easy language. If you see my screen, there are some alien looking things to you. These are programming language through which we create our model in real life. But for the beginner, and if you have interest, you can use Orange and you can save your so much of time learning Python and all this. But in future, if you want your career in AI, you need to learn Python and you need to learn so many libraries about AI and machine learning algorithm. Coming back to our Orange tool. So for now, I'm using SVM ML algorithm. I connected it with the test and score. So now 3 models have been created. Similarly, you can create all other models. So now you are seeing the accuracy of 93%, 95%, 89%. These are on the training data set. For me, more important thing is what is the accuracy on the test data set that it has not seen so far. So how will I see that? I will use prediction, and I will use prediction on the 30% data which the machine has not yet seen. So I will connect my data sample with the prediction, and this time notice I will change my data sample to remaining data, not the data sample originally. Otherwise, it wouldn't make sense. It would not predicting. It is the same model that was trained on that data set. So next, I will be connecting I have connected my prediction, and I will use the same model and connect it with the prediction visit. That's how I can test. So if I double click on this now, you can see my data set was originally this diagnosis column was there, radius, mean, all the values were there. Now on the left side, I can see that my tree model is predicting how it is predicting. So if I expand it a little bit, I can see for the first row, it's according to this 97% chance are there that this particular nucleus is malignant. So it has an error of around 3%. So for second one, again 97% accurately it predicted that it is malignant. For the fourth row, with 99% accuracy it predicted benign. But is it correct always? Generally no. Even it might get wrong, like here it is. So with 100% accuracy for the row 48, this particular nucleus, the machine predicted that this has a benign nucleus, but in reality, in our data set, it was found to be malignant. So here machine was wrong. So that's how we can visualize how machine performed, or the algorithm created our AI models performed. So on the test data set, the accuracy came out to be 93.5%. It is shown at the bottom. Similarly, we can connect our random forest with the prediction, we can connect our SVM model with the prediction, and we can see it in a single screen like this, that our random forest model performed with accuracy of 95.9, and SVM had an accuracy of 88.8. Here SVM didn't perform that very well. In the same way, we can see all the values, the 30% data set on which it predicted. So we can see all the values, and we can also inspect that where the machine is failing to diagnose. And we can analyze that why this machine AI model is failing to predict our diagnosis. If we find out the cause, we can work on the solution, and ultimately it will make our model the better. So that's how we create a basic model. As you can see in predictions tab, our model performed with an accuracy of 95.9. But in reality, in my practical research, my best model performed was 98.6, and it was SGD, stochastic gradient descent. So there are so many things inside each and every model. If I double click on this, there are so many settings. What are these settings that I need to learn with time? On day one, you don't need to learn it. If you want to practice like this, it would be easier. Another thing that you can do is you can create a ROC. With the ROC curve, you can decide, like you have seen in many research articles here, what is my best performance, best performing models are there. So I can see for benign which performed better, for malignant which performed better. So this way we can use ROC analysis. Another thing that we can see is one of the statistical analysis in evaluation metrics we do is confusion matrix. So if I connect confusion matrix, it will perform so many evaluation. For example, what are my true positive, true negative, all those kind of value for each and every model are there. From the top, I can change the number of instances to proportion of predicted, all those sort of things, like 83%. It was accurate in case of detecting the benign, while there was some confusion in 16% of the data where actually it was malignant and predicted was benign. But yeah, the good news is for the machine, actual were benign and machine predicted all those as benign. So like this, we can analyze. This is a basic workflow, very basic workflow. I'm clearly saying it. This is not all. There are so many things in Orange itself that we can do to create a better model. We don't require Python programming for that. But for today, in the beginning session, that would be all from my side. Because apart from, if I go into much deeper side, then it would be difficult and overwhelming for you for the first talk. I hope you got some points from this. If you have any question, you can ask. Sir, I'm open for question now. And if there are any question in the chat box, please let me know. I will check from the bottom.
Sir, in the Q&A, sir, you can see there are a lot of questions.
Okay. So one of the question that was I'm taking from the bottom, how can we use this technology in our daily practice? So right now, out of the box, you can't use this particular model. Like this model is there. If I click on save model, there is an option to export our data and create a model. But out of the box, just by this, you cannot use it in your real life as of today. You can incorporate it with your particular problem statement. I demonstrated you on the morphometric analysis of breast cancer FNAC features. First thing you need to understand that this data set was not just created in a day. If you have seen how morphometric analysis is done, you might easily understand that how this data set is created. In morphometric analysis, we put the slide under the microscope and it connects with the software part where each and every nucleus we can label it and we can create a particular parameter, for example, area, texture, diameter, all those kind of features. And ultimately, what even my thesis topic was on morphometric analysis of thyroid diseases using FNAC features. So that's how the morphometry part I learned. This was some 4 or 5 years ago. But nowadays, from that morphometric data, we can create our model. So if we create our model and we can incorporate it with the existing software, that's how we can use today's example. There are certain examples that you can use it in real life. If you have seen, there are some machines which are predicting in all the peripheral blood film, that reporting is being done automatically now. I think even Mindray has some machine about that can predict all the WBCs. So now time is changing quite fast. We can even forget that now we used to perform the PBF reporting by ourselves. Okay, let me show you. So this was a model that I created earlier some time back. So this was created with the intention to predict all WBCs and platelet blast and all those kind of things. So my aim was to create a model so that even if there is a single blast on the slide, subleukemic leukemia or aleukemic leukemia, those sort of cases. So if I submit my slide to the model, can it predict it? So that's how we can use it in daily life. It is not like just one talk you can decide, okay, I will be doing this in my day-to-day life. You need to find out your own problem statement and you need to figure out that how we can do it. We can solve the problem and we can incorporate in the real life world. That is ML ops, machine learning operating, or DL ops, or nowadays you are seeing ChatGPT. So it is like NLP ops. So all these are the deployment aspect. It is not a one-day kind of thing that I can teach. So another question is it possible to apply more than one model, one over another to combine? Yes, that's what I wanted to show you from this also. For example, this one was a complex model. If I want to make it more complex, there is a slide, whole slide scanning was done. First thing, I need to create a model that can identify that there is my tissue, there is my smear on the slide, that it's to differentiate between the blank glass with the tissue or the blood cells. So first model would be that one. Second model would be to differentiate between WBCs, RBCs, and platelet. My third model would act as, okay, classify the WBCs. Fifth model, if I create, that would further classify. There are research, just last week, I was reading a research article shared with me by one of my senior, Dr. Amnish. Sir, he shared an interesting article with me. There are machine learning algorithms that can even differentiate between AML and ALL blast. So layer by layer, we can create our differentiating features through multiple models, and then we can incorporate all those models in a single box and we can deploy it on a server and we can further use it. So next thing, Sonal ma'am, she is asking that if I can show you briefly about the neural network. Ma'am, here I can use neural network so easily that from data sampler, I just need to use neural network. It is using many neurons, as can be seen in the image itself. There are so many layers. If I double click on this, here it is, number of hidden layers. It is 31. It is using activation as ReLU. It is one of the most common, you commonly used activation mechanism. So this is the feature by default. It has been chosen. It is choosing. It is up to me how many hidden layers I can use. But since this is an easy problem, I will be using the default setting. I just need to connect it with the test and score. And second thing, I will be using the prediction. In the prediction, if I see that it has an accuracy of almost same as random forest with the default setting, that is 95.3%. So I need to tweak my neural network, the hidden layers and the activation layer. So that is little bit difficult, and I think all others, around 100 participants are there. They might get tired if I discuss the neural network in this talk. But yes, as a pathologist, it is one of the most important algorithm that ma'am correctly mentioned, neural network. These would be our future bread and butter. Like in histopath, we are saying even technicians are doing PPF reporting at some places. Let's not go into that aspect, but yeah, histopath reporting, it is still with us. But nowadays there are models, there are very good models that are doing histopath reporting by themselves. So those are using neural network. So in upcoming days, this would be our bread and butter, as per my opinion. Next question. How do we create our data set? Neha ma'am is asking. So to create our data set, first we need to figure out our problem statement. For example, just now I showed you two types of problem statement. One was prediction, breast cancer prediction using FNAC features. And the second one was create a PPF reporting automatically. So that is my problem statement. You need to figure out your problem statement. Depending on your problem statement, you will have to figure out how or what are the different things that you require. Do you require a numerical or categorical values, or do you require images? For just now I showed you a RoboFlow, my RoboFlow account, where I was showing you platelet and WBCs, how these are segregated. So it completely depends on your problem statement. One of the question was, what is the meaning of word worst in the tree? So here the tree in this data set, whoever created this data set, there were 10 parameters. You can read about those 10 parameters in the article that I have shared. There are 10 features, radius, texture, parameter, all those were there. And there were 3 types of values derived from these things: mean, standard error, and the maximum value, that is the worst value for every single parameter. So that's how they derived all these values. This is for this particular problem statement. You need to understand, for your problem statement, the data set would be completely different. It won't even look like this until and unless you are working on the same problem. Another question was, what is specification of the system, specifically GPU, for running image-based ML? Yeah, very good question, because for the pathologist, image-based deep learning algorithm, that are the most important things that we need to figure out. Today, I demonstrated you a very easy one that was using machine learning algorithm only. But even though it was easy, I had been using my GPU for quite a bit. I am using 8 GB of dedicated GPU right now, and even actual machine deep learning models I can't use even in my machine, which is 32 GB RAM, still, and 8 GB of GPU. Still, I am using only it only for prototyping, not creating actual model. For those, I use Google Colab, and if there is data sensitive, and if I need to follow HIPAA guidelines and all those things, then I will use AWS, the Amazon server from Amazon. That is costly. So you need to have some research grant, because around it might cost somewhere around $1 per hour if you want to create your own model. Creating your model on those, that would require another some 2-3 hours of webinar if you are new to it. So you need some heavy GPU basically. Building an AI model now comes doable. Okay, so one of the anonymous attendee has asked that if they don't have time to learn Python. Yeah, I always say that first thing is you need to figure out yourself what is the aim that you are attending this webinar. Do you want to learn about AI? For example, I am a big fan of all these kind of technology. So that's why I learned it professionally. I did a diploma. I'm doing a master's in this. But for what is the requirement for you? Do you just want to learn for basic knowledge? Then it's fine. You just need to know some basic algorithm, step-by-step approach that I shown you in the PPT. But if you want to work, or you want to create a good research, you have a problem statement and you are seeing that none of the other people who should be working on this have not performed that much, you have something to produce extra, then you can figure out your problem statement. If your problem statement has an option that without using programming you can create. For example, today I showed you using these Orange tool. There are so many tools, AutoML and other tools are also there. Google has some Teachable. If you see in this, if you are using image-based thing, so you can learn how to use image-based. For example, earlier I showed you how do I classify all 5 types of WBCs. I can provide as a class 1 neutrophil, class 2 as my lymphocyte. Similarly, I can provide all my images to it and create train model same as I was using in Orange. So this is a free of cost tool. That's how it is showing me. For example, this is a demonstration. I am hearing some background. Okay. So the next question is, what should we enter in the output table name? Sorry, I didn't get your question. Output table name, maybe here. So, like I mentioned, every widget has on the left side some input node and on the right side some output node. These are, I think by now you might be knowing how these are connected. If I am not able to get what you want to ask in this question, can you please elaborate in the next comment? Microscopic slide into data set, software for the same. So, ma'am, as I discussed earlier, this particular data set was created using morphometric analysis. Mostly medical colleges have decahead or pentahead. Their computer comes with the decahead, and generally there is a software attached to it. And also there is another company named as MedPrime Silica. Some of you might have seen the microscope of those. I use it frequently, this one. So in this, I can create my data set myself. Here, I can connect my tab with the microscope itself, and I can annotate my create my data set like easily. So since I don't have a pentahead or decahead on my own, I use this technology. So again, it would depend on your requirement. By using AI, will lab technician be able to diagnose PBF, FNAC, histopathology? Unfortunately, in upcoming few years, yes, if they know how to handle the machine. So, like there are 7-part, 10-part, 9-part CVCs are there, and even technicians are running that, and printouts are going outside. Yeah, it is scary, but yes, I am afraid if there are. So that is an ethical aspect of using AI and creating the models and deploying it in the real world. Who should be the signing authority for these particular reports? He should have good knowledge. As I shown you, there are false positive and negative in this simple data set. This was a very curated data set. Ideally, it can be accurate as 99.1%. I have seen one research someone did. He proposed a method by which this data set has 99.1% of accuracy. So the technicians might not be aware of those kind of things. For accuracy, he needs to understand how the nucleus looks like under the microscope and the AI algorithm, how it is diagnosing. So it would be difficult for him to, but yes, if certain guidelines are not made clearly, then it would be very bad for even for the patient also, because then everybody will be taking out the printout for the whole slide. Okay, Avnish sir has mentioned, he has replied to some of the questions. Numerical value to non-numerical feature, I have answered. Training set and, okay, so Sagar sir, he has asked that what is training set and validation set. So basically, I have some, for example, 500 rows of data, out of which I will decide 300 rows will be my training part that would be used to create our model. The remaining 200 rows or the data, the machine has not yet seen. If I go into actual AI, the big companies that they are using 3 types of data set. First one is training, second one is for validation, third one is for test. So training would be to create our model. Validation would be testing our model during the creation of creating time. For example, here I shown you that in case of validation, my model performed 95.9% accuracy. Now I will tweak some settings from my tree visit from random forest, and again I will see my prediction. So that would be my validation. Ultimately comes the test part. The test part in ideal scenario would be on our final product. But if we are like in the beginning phase, generally we use train and test data. We don't use the validation part. So these were all the questions. I think I answered all of them. But yes, there are some more questions. Do we have actually to create our own data set of our police? Yes, Dr. Prachi ma'am. Generally, we should create our own data set. There are some free data available. You just need to Google it. You can practice on those free data set, but for larger population, we should create our own data set, because in that way only we can create the model that will be working better in our institute or at generalized. For example, AIMS might be having some good quality of H&E stain, but in other colleges, it might not be of that brand, that it might not be of that good quality. So generalization would be there. So that's how we can create a generalized model. The data set which I am providing, it is very curated. On the net, you will find the free data set that is from US. Their slide images are very good quality. So if a model is created for those slides, if our slides is not that good in staining, if some hematoxylin is more, our model will perform, that model will perform badly. But if we create a model on our slides, that would be the best thing. So yes, Dr. Prabhat sir has mentioned that most manufacturing providers some pre-installed AI software like Mindray. Yes, from the last talk that we was on AI in the same group, they demonstrated that there is automatic PBF reporting is there, and even in some machines, Mindray is also providing. So it is by default being incorporated into the machine, and it is time for us to get aware of these things, and we can provide our input to the machine making people. Why I am saying so? Because as a doctor, we know better, or as a pathologist, we know better how, what do we want. If on time we didn't answer these questions, or we didn't give our input to the companies that are building the machine, then we will be lagging behind. For example, even in US, UK, the doctors are facing a problem that EHR software that they are using so much frequently. They face difficulty. I have been into some of the groups, and I have heard them that they are facing difficulty in that software because they wanted something to be categorized, for example, as a subcategory, but the software creator company has not done that part. So because earlier the doctors were not asked what do they want. if we know this much of basics, then we can tell our counterpart, the engineers who are creating the machine, that we want this particular type of thing. We want to diagnose this. Since I have already overshot the time, I won't be showing you. A few days ago, I got a gig of about $20 that we need to create a model that would predict the breast cancer in a mammogram. And interestingly, the engineer who presented this problem to me, he's supplemented the data set of histopathological slides. And I was like, you want to predict a model on mammogram using histopathology. So basically, he doesn't know that there is some histopathology slide, there is some cytopathology slides, and there are mammograms. For him, it was like a breast cancer slide. And somehow he wants to create a model and incorporate into mammography. So we should be aware of these kind of things so that we can solve these kind of problems. I think I have answered most of the important questions.
One is remaining. What will be the role of pathologist in AI era? I think you should answer that also.
Yeah, that's another very good question, because most of the times I get asked this kind of question that if I'm some time ago only, I got a call from one of the budding PG. He got selected and he's from Mumbai, I think, and he's getting MD pathology in this currently running counseling. So he asked me that whether I should take MD pathology or not, because most of the people are saying that pathology will be outdated. So I want to say that not in our working years. I don't think that it can replace it. It will be aiding us to get to know better diagnosis, but it won't be replacing it. Our role would be to diagnose same as before, but using AI assisted technology, so that even the smaller institute can give the better diagnosis. For example, in my institute, as of today, ISCs are not happening. So if a breast cancer patient comes and if I need to do ER/PR analysis, I don't have the resources for him, for her. I need to refer her to higher center, or I need to send the block to higher center for ER/PR analysis. But nowadays there is a technology named as GAN, generative adversarial network. If you can find on Google Scholar, you can easily find that nowadays the algorithms have been created. They are in validation phase, that from HND slide, how can we create our own ER slide? So from HND itself, they can predict what would the patient's ER slide would look like. Similarly, PR slide would look like. And the models are very good. That is again an afraid that would make us afraid. But at the same time, if we know how to use those kind of model, in my institute only, without using ISC machine, I can use that. Okay, this patient would be ER status would be either positive or negative, depending on the validated FDA approved model. So I can treat, I can diagnose better in my center, but only if I know such kind of technologies exist, they are validated. That's when I think I will remain significant. For others who are not getting up to date and stuck on the traditional aspect, then it is little bit difficult if you are in my age group. Then because technology is changing severely since last 2-3 years, and the speed of change is very fast as compared to 20 years ago. So it is same as if some of my teaching faculties used to ask me during PG, when I was working on morphometric analysis in my PG, that your research might make pathologists outdated. And I used to say that respectfully, ma'am, 20 years ago or 25 years ago, there were only 3 parts, or there were only that the counters were there for manual PBF reporting. Nowadays, there are CBC machines. Even every institute has 7-part differential machine. Have those machines like created some pathology deficiency? I don't think so. They have aided us in creating better diagnosis. Earlier, we can say only leukemia. Nowadays, we can classify it further using flow cytometry. So I think it will help us create in better diagnosis if we use it wisely. And we have proper ethical licensing there. If it is in common domain, if anyone from home can use the model without even knowing the context, then it would be very bad for the patient also and for the doctor also. So even ethical aspect is a debatable topic. So that's all from my side, Dr. Prashant sir. If I missed any question, can you please point it out?
Somebody is asking, Dr. Prashant is asking, can you suggest accurate software and microscope for morphological analysis in India?
That is literally, I can't just name any single microscope and software. Depending on what do you want to achieve, you might ask it later on. It's not like if I'm promoting a single company for microscope. Someone asked me how I can do the morphometric analysis in my on my own without using the institution fund. Then I gave example that, for example, I am using the MedPrime technology silica microscope, because in that I can attach my tab and I can do analysis on my own. So depending on your problem statement and what do you actually want to achieve from that microscope and software, because it is not a single, there are not a single software. There are some free software, some are paid. Image is one of the free software for the longest time I have ever seen. For more than around 15 years, there is this software Image that is used for pathological image analysis. This is one of the most important and popular aspect of that software. There are many more are there, so I cannot just name a single software. And one more question is there, career option after taking it up. It depends on you. For example, due to some of my commitments, I will be settled in Rajasthan only. I can't go to any other state or district for workplace. So if I get a better opportunity from Delhi or Mumbai, I can't go there. It depends on you. If you can go there, there are so many research are going on. Active research are there. Some of my seniors are doing some very good research that is far much more advanced than what I showed you today. So if you know better, you can apply for that job. It would be a very good opportunity for you if you know these kind of things, because nowadays even in India, as Indian government suggested, Digital Bharat and all those schemes are there. For that, the big institutions are getting some research grant, and they are creating their own model that can be used in Indian population. So there you can use it. So that was all from my side. There are some advanced aspect of this Orange and AI, some of which I teach in Udemy courses and some on series of webinars. So if you want to know details, you can further connect with me. Feel free to connect with me. My mail ID is atultiwari.in@gmail.com.
I think there are no more questions. And it was an excellent webinar. I want to express my sincere gratitude to Dr. Atul for delivering such an insightful and engaging talk on use of AI. Your expertise and passion for the subject truly shone through, and we found the information you showed to be incredibly valuable. Thank you for taking the time to educate and inspire us all. Your presentation has left a lasting impact on us. Thanks a lot, Atul.
Thank you, sir. And good
And
night.
one more thing, that we will be having a series of webinars in September also, and that will be notified on our WhatsApp app. So please take out your time on Saturday evenings. We will be notifying all the details on our WhatsApp group also. Thank you.
Okay, bye. Good night, all. I'm ending my presentation.
Thank you, sir. Bye.